All right, I'm going to go ahead and do a second video on average rate of change. First off, remember, whenever you see the word rate of change, we're dealing with slope. Now, a secant line, we're specifically dealing with the slope of a secant line. The reason they say secant line is because we're typically dealing with non-linear equations. So for instance, it could be a quadratic. And as such, if you have two coordinates on that quadratic, the slope of the secant line is the line that passes through those two coordinates. And I totally missed those, but we're going to pretend I was right on. Oh, boom, right on. Okay, so that line I drew in black is the secant line. Okay, so that's all that last part's saying. Now, slope between two coordinates, this is the formula for slope between two coordinates. So if I ever ask you to find the average rate of change, that's all you're doing. You're finding the slope. So here's an example problem. We're finding the average rate of change, or the slope of that secant line, from -1 to 3 of this function. Okay, the two numbers they give you are the x values. They're giving you an interval along the x-axis. So that's x1, or vice versa. Doesn't matter which order you choose. But I'll go ahead and say -1 is x1 and 3 is x2. Now remember, we are putting it into the slope formula. So y2 over y1 over x2 minus x1. So we already know our x2 is 3, our x1 is -1, or you can reverse those. So the question is, how do we then find our y2 and y1? Well, that's what this function here is for. F of x is the same thing as y equals. So to find y2, you simply need to plug in x2. So I'm going to go ahead and make a table to do that. So I'm going to plug in -1 for my x1 and 3 for my x2. So if I plug in -1 into that whole function, you get +4. And if I plug in 3, I'm not going to write it out this time, you get 24. So 24 is our y2 since our x2 is 3. So I'm going to do the 24 first. And then our y1 is 4 since -1 is our x1. And then I just need to simplify this expression. So 24 minus 4 is 20. 3 minus -1 is 4. You get an average rate of change of 5. So the slope of the secant line, so the line passing through the coordinates at -1 and 3, is +5. I'm going to go ahead and do one more where it's a little more complicated. So I'm finding the average rate of change, or the slope, this time from 3 to x. So notice they don't specify the second term. That's okay. You're still doing the same thing. So y2 minus y1 over x2 minus x1. So let's go ahead and say 3 is x1, x is x2. So I can go ahead and put that in the formula. So we have x minus 3. And then to find your y1 and y2, once again, you got to do a table. So 3 should be easy. I plug 3 in. 3 squared minus 2 times 3 is 3. Now, if I plug x in, this may seem counterintuitive, but that's plugging x in just means you're getting the exact same output, or the same definition. So x squared minus 2x. So I have x squared minus 2x will be my y2, and then minus 3 is my, so we subtract y1, so 3 is our y1. Now, this problem, you do need to simplify. So I do need to factor this top, or the numerator. So x squared minus 2x minus 3, just a little refresher on factoring. So if your first term is just x squared, where there are 3 terms total, then the first term in each set of parentheses will be an x. And that's because x times x gives you x squared. To find the last term, you find the factors of your last term. So the factors of 3 are 1 and 3. And to figure out the signs, I just need to figure out how I can, or which number needs to be negative so that when I add them together, I get -2. So a -3 plus 1 would give me a -2. Okay, so when I factor, I get x plus 1, x minus 3 over x minus 3. Now you're going to notice that you have a common factor, or a value you're multiplying on top and bottom. So it's x minus 3. So you can eliminate that common factor because when you divide them out, it's equivalent to 1. So your final answer is just x plus 1. So let's go to part B, because part B is kind of interesting. So we're finding the average rate of change from 3 to x. Notice on part B, it's from 3 to 6. So from part A to part B, the only difference is the x is now a 6. That means we can use part A in our answer. We have an answer of x plus 1, right? Well, x is 6. So I'm using part A's answer, that x plus 1. I'm changing that x to a 6, which means my average rate of change, or my slope, is 7. I want to do one more problem related to this. This is actually part C. I just didn't have room to fit it all on this one page. So we are actually going to use this part B, the answer for part B. So remember, we just found the slope of the secant line from 3 to 6. So part C says to find an equation of the secant line containing 3 f of 3 and 6 f of 6. Well, I'm going to go ahead and find the coordinates for each of those. So 3, when we plug it in, f of 3 is 3. 6 f of 6 is 624. So we have 2 coordinates right here. So we need to find the equation of the line. We just need to find the line. So I want it in the form y equals mx plus b. You can do this in multiple ways, but in part B, we found that our slope was 7. So I can go ahead and just say this is y equals 7x plus b. So how do I then find our b, or our y-intercept? Well, since neither one of these x values are 0, they didn't give us the y-intercept. However, we can use either one of these coordinates. I'm going to use this one. You can choose whichever one. And I'm going to plug 3 in for x and y into that equation. So I'm going to do that down here. So we have 3 equals 7 times 3 plus b. So 3 is equal to 21 plus b. And when you solve that, you get b equals -18. So from there, we know that y equals 7x minus 18. And there's your equation of your secant line. You can double check that by plugging in 6 for x and 24 for y. So 7 times 6 minus 18 should give you 24, and it does. So there you have it, average rate of change.